Good afternoon, everyone. So, in this video, we'll be talking about advanced object and class concepts. Okay. So, as part of this video, we'll be talking about enumerations. Okay, multiplicity, and then scope and visibility. Okay. So, what these things are. Okay. So, we'll be looking at all these things. Okay. Enumerations. So, a data type is a description of values, more or less. These things include numbers, strings, and enumerations. Numbers and strings we have already seen. Okay, let us look at what are enumerations. Enumeration is a data type that has a finite set of values. Okay, so something like, say, for example, a country code. Okay, which has values such as, say, for example, for India it is IN, E for Estonia, and US for United States. Okay, UK, and D for Germany, etc. Like these things for countries. Okay, so now if you want to put these country codes all of them together, okay, that will make an enumeration. Okay, what would be the advantage of that one, we'll be seeing in the coming slides. So similarly, if you basically try to see, okay, for example, say for example, we have already discussed about this figure class while discussing the generalization concepts. Okay, so the figure class has a pen type. Okay, the pen type can be a straight line, okay, a dashed line, or a dotted line. Okay, so basically, if our application has only those three types, so it has a finite set of values, then it is better to represent them using enumerations. Okay, so that's what we are actually looking here. So similarly, in the last example, we have seen these two-dimensional field types. Okay, so two-dimensional field types, the field types can be fully black, or the color can be gray. Okay, with fill type. Okay, with fully filled with black color, fully filled with gray color, or there is no fill. Okay, so none or null, or the fill type can be okay, so these dash, so horizontal straight lines. Okay, so like this one, or it can be even the cross lines. Okay, so these are the different types of field types in the two-dimensional class which we have discussed earlier can happen. Okay, so then it is also good to basically represent these things as enumerations. Okay, so more or less, enumeration is a data type that has a finite set of values. Okay, wherever it matters, so we should be using it. When constructing a model, we should carefully note these sort of enumerations. They often occur, and then they are very important to the users. Okay, say for example, if you think about an example of say for example, some application about some calendar or something which you are developing. So then the seasons are four. Okay, so for example, winter season, summer, and then autumn and all those things. Okay, so these things again can be represented as an enumeration, or even say for example months of a year. Okay, January, February until December, you can actually put them as enumerations. So any finite set of values, it is good to represent them as enumerations. Enumerations are also very significant for implementations are concerned. Okay, say for example, if you are developing an application, say for example, like HTML application, or with visualization, with GUI associated with this one, then it is possible to display all these values with a drop down list. Okay, you click the list and you will have all the enumeration values one after the other coming. Okay, you select one of them. Okay, and you will put that as the input. That way, you are actually eliminating all these sort of illegitimate input. Okay, so you will be basically putting fixed input. Say for example, a boolean type can be true or false. Okay, so if you basically give them a specific area, so some may put with capital T or UE, or some may put wrong spelling as well. Okay, some may put small cases. Okay, some may put capitals. Okay, why to do all those things? So have a drop down list. Okay, so and then you just mention true or false. Okay, so then all the input will be legitimate for that particular data. Okay, of course in UML the enumeration is a data type. It will be represented by this sort of this limits. Okay, so that means these two less than and then two greater than symbols, anything in the middle. Okay, so they are called limits. Okay, um, of course once you are declaring this sort of enumeration. Okay, so at the top line it will be between, you will be giving the enumeration name there, and then enumeration values you will be putting in this sort of bottom space. Okay, in the second compartment, more or less. Let's see that. So to give you the hint, like here is some enumeration, okay, so which is suit, okay, so I will talk about that, okay, it has different values, okay. One thing, do not use a generalization to capture the values of an enumerated attribute. This is something very interesting and then like important to remember. An enumeration is merely a list of values, okay, but generalization actually means, like we already have discussed that in generalization, okay, in detail, so we don't have to go in depth again, okay, so you have to check the other video. But generalization is a means for structuring the description of objects, more or less, okay. We have to introduce generalization only when at least one of the subclasses has significant attributes, operations, or associations that do not apply to the superclass. Okay. Say for example, like use generalization only when. Okay, so it is very clear. Like say for example, only when at least one subclass. Say for example, there can be several subclasses, but at least one of the subclasses of the superclass has significant attributes, operations, or associations. They differ from this sort of superclass, and then like they do not apply to the superclass in clarity. Okay, let's look at an example. Okay, and then like let us see like where enumerations can be. Okay, so should be used instead of generalization. Okay, so this is about playing cards. Okay, okay, so for example, like there can be different cards. Okay, different sets, bunches, and then like the cards will have different suits. Okay, so which will have base spades, clubs, or hearts or diamonds. So each card will have a rank, something like, okay, so ace, 2, 3, okay, up to JQK, okay, king, queen, okay, jack, etc. Okay, so you can have that sort of rank as the card type, okay, and then like you can have this sort of subclasses which actually can extend this one. Okay, so this is the generalization. The generalization here is at the suit level, okay. So different types of suits are there: spades, clubs, hearts, and diamonds. Okay, this is one approach of basically representing that class. Okay. Alternatively, okay, say for example, but the problem here is like going by the same discussion above. Most games do not differentiate the behavior of spades, clubs, hearts, and diamonds, isn't it? Okay, they are approximately the same. Okay, so they do not differentiate the behavior for most of the games. But then, like, how do we basically represent such as classes? So then you can actually represent it like this one. Say, for example, you can have a card class, okay, which has the suit of enumeration type suit, okay, and each can also have a rank which is of enumeration of rank. Because you have finite set of suits, okay, so you can have one enumeration, okay. So I was talking about this UML representation, which is enumeration, which is suit, and then like we can have this sort of spades, clubs, hearts, and diamonds. Okay, so that's it. A pack of cards will have only these four suits. Okay, so then you can actually represent by an enumeration. So and then like say for example for the rank as well. Okay, so then you have only 13 different types of cards, isn't it? 13 different ranks: ace, king, queen, jack, and then like 2, 3, 4 up to 9. Okay, so basically, okay, so if we are trying to design a playing cards game, so it is better to represent, okay, so this is not the ideal model, so with this sort of generalization, but rather we should be using the enumeration. Okay, hope that's clear. So that's about enumeration. Now let us look at multiplicity. Multiplicity is a constraint on the cardinality of a set. Okay, and this is discussed for associations. Okay, we already have discussed it for associations, but it also applies for attributes as well. Okay, especially for database applications. So these are really critical actually. Okay, say for example, like multiplicity of an attribute basically specifies the number of possible values for each instantiation of an attribute. Okay, say for example, if you consider this person, okay, he can have name only once, isn't it? That means like it's a mandatory single value. Okay, but then like there can also be an optional value. Okay, say for example 0 dot dot 1. Okay, so then if you give that one for that particular attribute, okay, so it is an optional value. Say for example null value in a database. Okay, so you can have that one. And multiplicity also indicates whether an attribute is single value or can be a collection as well. Okay, say for example if you put something like a star it can have many values. Say for example, a person can have several phone numbers. Okay, so there you will basically put like a string with star. Of course, address also, like you can have multiple addresses, but there should be at least one address. Okay, so that means like it is one dot dot star. Okay, and then like again, like the birthday should also be a unique and mandatory and a single value. Okay, so you can also define this sort of multiplicity at the variables as well. Okay, so this is a simple concept, and then like it is easily understandable. Now let us look at the next concept, which is called scope. Scope is very interesting. Actually, scope indicates if a feature applies to an object or to a class. Okay, say for example, here we are seeing like a lot of features. Remember, always feature means both these sort of attributes and also the operations. Here we don't have the operations, but then like it also can be for operations. Scope basically indicates if a feature applies to an object or a class. Okay, and underline basically distinguishes this sort of feature with class scope. Okay, we already know about them in the Java programming. We have been seeing. So any feature which is for the class, we are calling it as static. Okay, so that means that is unique for this particular class itself. Okay, and then like that is how like we can actually distinguish these features with those object scope. I mean like this underline distinguishes them in this sort of UML representation. Where do we actually use a scope? Okay, so there can be several places where why we should be using it. Scope for attributes especially, it is acceptable to use an attribute with the class scope to hold the extent of a class. So this is again a concept from this sort of object oriented databases. Extent, basically like extent provides you with access to all the persistent instances of a class, and optionally subclasses as well. So in object-oriented databases, like they basically create all these objects of a particular class. You will be putting them into a single attribute, and using which like you can actually access them. Okay, that is basically called as extent. So in such a case, like it is advisable to use this sort of class scope that is basically static for this sort of attributes. Okay, or any global variable if you want to use, it is also good to basically use them with this sort of static variables. But most often it is ideal to avoid them. Okay, we should be actually avoiding these attributes with class scope because they basically can lead to these sort of inferior models. Okay, let's see an example why it is so critical. Okay, let's look at an example. Here is a phone mailbox. Okay, so let us discuss this one. Okay, so basically like a phone mailbox will have a particular phone number. Okay, so it will have a password and also like it will have a greeting message. Okay, mailbox, I mean like it is associated with a person. Okay, the person will have a name. Okay, and then like the person is the owner for that phone mailbox. Okay, so this is like see where the association is multiplicity with star and one. So one person can have multiple phone mailboxes. Okay, great. Now the point is max message count. Okay, for the phone mailbox, you can have it as a static variable. So this is class level variable, max message count. Okay, so this is a constant for all the phone mailboxes. Okay, so for all these phone mailboxes used by different persons, max message count. Whereas like other variables are like these sort of object variables, phone number, password, and greeting. Okay. Now assume like say for example that phone mailbox will have multiple phone messages, isn't it? Okay, that's the basic idea. Okay, phone mailbox. The phone message itself can be like have again like static variable stating like what is maximum duration of a message. Okay, so that means like again you are fixing what would be the maximum duration of a voice message like which you record. Okay, and then like maximum days like you will actually retain them. Okay, so this is a particular phone message. Okay, and on the date which it is recorded and the time when it is recorded. Okay, what is the priority of the message, what is the message itself. Okay, and then so and so lot of things like you can basically put, and then like you can also have a variable like has been received. Okay, whether the message has been received, because like a phone message can be actually generated by a phone mailbox. Okay, so that's how like the source you see like this association, so it is either 0 to 1. Okay, so it is either generated by a phone mailbox, some other mailbox actually has sent mailbox to this phone mailbox, or like it can be generated from some other sources. Okay, so some automatic messages or whatever it is. Okay, so for understanding this one, like it is not so critical. Okay, for this example, and then like once again seeing like a phone mailbox. Okay, will have an owner. Okay, so it will have several phone messages. Okay, okay, and then like these phone messages are ordered. Okay, so we have seen all these features with respect to associations. Okay, of classes. Now good, this model is perfectly okay, so there is no problem with this one, but the thing is like you cannot extend it. Okay, say for example tomorrow you want to have multiple persons having like different types of phone mailboxes, having say for example the each of the phone mailbox may have like say for example its own maximum message counts. Okay, so for example a cheap phone will have a fewer number of mailbox message which can be stored, and in a say for example an expensive phone and then like which has a lot of features can store a lot of messages there. Okay, with a lot of storage it is possible. Okay, and then like say for example you can store the maximum duration also, like you want to vary per phone and per person. Okay, you can't vary with this sort of model. This would be a little bit restrictive model in that sense. Alternatively, what we can do is like we can actually take these class level attributes out. Okay, okay, more or less the static attributes out, and you can actually group them into another class. Okay, so we can put another mail category with respect to this phone mailbox. Okay, and we can have say for example like each of the phone mailbox can have one mail category associated. Okay, so the mail category can have its own category name, and then like it can have this sort of message maximum duration. Okay, message max days retained. Okay, and then like message max count. Okay, so you can have this sort of another class for that one. If that is the case, then this model is extensible. Okay, so the way like I said, like say for example if you have multiple types of phone mailboxes, now you can achieve with this model. So the above model is a little bit restrictive, and then like this is the preferred model for that one. Okay, so this is about scope variables. Okay, so scope for the attributes, when it is ideal to use and when it is not. Okay, so that's clear. In contrast to attributes, okay, it is acceptable to define operations of class scope. Okay, the most common use of class scope operations is to create new instances of class. Say for example you can actually have a constructor. Okay, so we have seen in Java, so we can have a method which actually creates instances of a class. Alternatively you can even put the constructor as static. Okay, so then you can't even create any classes. Okay, so only you can have an object there, and then like that is the universal object, you don't want to change it. Okay, so you can actually achieve something like this one. Sometimes it also can be used basically like this I mean like this class scope operations, we can also use them for summary data. Okay, say for example for every class like you can have something which basically gives you the summary information of the particular class. You can achieve something like that. Okay, so that's about this sort of scope. Okay, and now let us look at another very interesting concept. Okay, which is called the visibility. Visibility actually refers to the ability of a method to reference a feature from another class. Okay, so basically like you are trying, you have a class one. Okay, so which has like these sort of attributes and then like operations. You have another class, okay, which has a method. Okay, okay, so method again like it is basically an implementation of an operation. Okay, so okay, which of these sort of features from this class A can be accessed by this method? Okay, that is actually shown by this sort of visibility. Visibility we have been discussing. Okay, we have been using even in Java as well. Now let me discuss them in detail. Possible values for visibility are this: public, protected, private, and package. Okay, any method can access public features. That's why like say for example until in the beginning of our labs we were using all these sort of class variables. Okay, so as public. Okay, so any method can basically access these public features. So that means like whatever that we are defining as features, so these sort of attributes we can actually access them. Okay, So only methods of the containing class and its descendants in terms of generalization. If there is a class A and then like there is a class B which is actually extending this class A, if anything is declared protected, okay, so let me clear it, okay. If anything is declared as protected in the superclass, it can only be accessed from its subclasses. Okay, if there is a third class which is existing somewhere else, even if it creates an basically like an instance of this class A, okay, it cannot actually access these sort of protected features. Okay, remember that one. So the features which are declared as protected in this sort of superclass, okay, can only be accessed by its subclasses. Okay, no other class. And if something is declared as private, okay, so only the methods of the containing class can access these private features. Remember that one. Say, for example, if we are declaring some of the attributes as private, only the methods of that particular class can actually access them. We have seen this one in the Java lab as well. Okay, that's how like we have created those getter methods and setter methods. Okay, so we had this sort of attributes of that particular class as private. We declared them as private. So we have provided like say for example these get methods and set methods. Okay, basically so that like these variables we can basically modify from outside. Okay, and we have given this visibility for these sort of getter and setter methods to be public. Okay, so that's about it. And methods of a class defined in the same package as the target class can access these package features. There is a fourth type as well. Okay, so this is called the package. The package, if at all any attribute or like a method is declared as package, say for example, I already have discussed about these packages. Okay, say for example in Java labs, like I have shown you, for every class, like I'm giving a package name, and most of the classes we are designing are put into a single package. Okay, now if you declare any of these variables as package, okay, scope, okay, then basically like only those classes, okay, within that particular package can access the features which are declared as package. Okay, in Java it's a little bit different. Java by default, if you don't put any scope, okay, say for example if you don't put any visibility, you don't declare public, private or protected, okay, then it is default. The default scope is actually the package scope in Java. So if you don't declare, say for example, if you declare like integer and then like some employee ID or something, okay, that means like if you have another class in a different package, okay, even if you create an instance of this one, you cannot actually access that particular employee ID, okay, even if you create an instance outside the package, okay. So in general, at object-oriented level, its scope is called, its visibility level is called package level. Okay, but in Java, like if you don't declare anything, okay, so default it is package level. Okay, remember that. So as I said, like there are different types of visibility. Okay, so with the UML notation, like if there is a plus, then that means like it is a public. Okay, so public feature, both attribute and method. If it is hyphen, so then it is private. So if it is hash, so then it is protected. If it is tilde, then it is like package scope. Okay. So we already have seen this example, an employee. Okay. So we already have seen this example by discussing the generalization concepts. So employee has an ID, he has a name, he has some salary. Okay. So we can declare all these sort of attributes as private. Okay, and this is what we have done in the Java labs. Okay, so we declared the variables as private, so we had these sort of getters and setter methods for each and every class. Okay, now say for example for this class is concerned, we have a display method. The display method, like we have declared the visibility to be protected. So that means like this method is visible only to these sort of subclasses. Say for example, a permanent employee can basically display something, okay, or say for example, if display is displaying ID, name and salary, say for example in a certain form, Okay, you can actually display it from this sort of permanent employee or from the temporary employee as well, because they are subclasses. Okay, since they are private, okay, even from a subclasses, like you cannot directly access them. Say for example, if I create an instance of permanent employee, I cannot put the permanent employee dot id. I cannot access them. Okay, so I need to access them to some getter and setter methods. Similarly, for the permanent employee, he has the CPF. Okay, and since this method is like he is giving like calculate EPF as public method, any class either within this package or from a different package, okay, different folder or package, more or less, you can think like that one. Okay, it can actually create a permanent employee object, and then like you can actually calculate the calculate the EPF. Okay, and similarly, say for example, the temporary employee we have already seen, like he has this sort of probationary period, which we can also see the progress. So here the restriction we are putting is like, say for example, it is a package level scope, a package level visibility. So that means like, so this can be, this method can be accessed by any method from a class within that package only. Say for example, if it is declared in, say for example, in dot um, AC dot okay, so basically like UOHYD, okay, dot SEIS dot Srirama. So every package, every class within that package can actually access this method, but no other class outside the package can access this. Okay, so that is the package scope. As I mentioned, like in Java, like if you have not mentioned anything, so then that means like it is of package scope. But generally coming to the UML level, like if a lack of prefix reveals no information about visibility, so that means like visibility is not null. Okay, so that is critical there. When you are considering this sort of developing this visibility, okay, so there are several issues you should be considering, okay, when choosing the visibility. One is comprehension. Okay, understand all the public features to understand the capabilities of a class. Of course, say for example, that's how like you are actually comprehending the complete model, okay, class model. You have to understand all the features, okay, all the public features to understand the capabilities of a class. Whereas like in the beginning, like you can actually ignore these sort of private, protected and packaged features. They are merely for an implementation convenience. Okay. So of course, again, I am saying like it is not just attributes. You have to look at the features. So going by the same example, like if I have an employee and then like all the variables, all the attributes as private. Okay, so don't say like nothing is relevant. Then you have the relevant getters and setter methods, isn't it? They will be public. So you have to understand all of them so that like you actually understand comprehensively understand that particular class. Okay, remember that one. Okay, that is again one issue we have to consider while choosing the visibility. If you are declaring a new class and then like what should be the visibility for different attributes and operations, we have to think about that. Extensibility is another very critical feature. Okay, when you have to consider about visibility, many classes can depend on this sort of public methods. Okay, because as we have seen, like say for example, there can be several instances created from this public class and then like class variables and methods, public methods. Okay, we use them and we will be extending them. So if you change any of this sort of syntax or signature of this sort of class, it will have serious implications. Okay, so it can be highly disruptive to change the signature. Okay, so anything which is declared as public, later like don't change them so freely. Okay, so making a private one public will not make much difference. Okay, but then like if you have anything public, you make it private, every class like which has actually created that sort of object of this particular class and then like using certain features which were public, okay, so in its source code or whatever it is, everything will be disrupted. So everything you need to change. So in terms of extensibility, you should be very careful when you are defining the visibility. So in the future, like if you feel like something has to be changed, it is better to plan well in advance. Okay, and context is also another very critical thing. Excuse me. Private, protected, and package methods may rely on preconditions or state information created by other methods in the class. Okay, Say for example, you have a certain private variable, okay, so which you are actually trying to modify in a public method, okay. So basically like it is like that one. So the state basically is created in a different method and then like it is maintained there, okay. And if you remove all that particular context out, okay, so applied out of context, a private method may calculate incorrect results or even cause the object to fail. So these are the things like which you should be considering while choosing the visibility. Okay, hope that is clear. So again, so this uh, information is actually taken from this book, okay, Object Oriented Modeling and Design with UML. So it is from chapter 4. Okay, so we are discussing about this advanced class model. Okay, thank you very much.